Now, a quick review of the IoT market. That's going to be 41.6 billion of the IO class devices interconnected in 2025, next year. And they generate almost 80 zettabytes of data yearly. The Gartner stated that in 2029, I didn't find the recent data, sorry, but in 2021, there was already 22.5 meter of the devices. So the next is like for 2025, 41.6. So we see that the growth is maybe not exponential, but it's at least linear over the time, as I can convert it. It's always like that, then it slows. But now it's on the rising trend. So this market is still hot, right? There's a lot of business opportunities here. This market is huge, and honestly saying, key players are those who manufacture electronics. So I say China, Malaysia, Singapore, Japan, South Korea, Philippines, Indonesia, Hong Kong as well, right? I mean, sorry, Taiwan. Okay, let's go quickly through the IoT system characteristics. First, end node devices. We just went through them, right? They're development boards, but there could be also already enclosed devices. Low power consumption, 1 to cores, up to 3. Wireless communication built in. RAM is kilobytes, megabytes, storage similar. Connectivity, GPIO, right? So we can connect those sensors and actuators. User interface is very limited, if any. Buttons, LED, eventually you can connect LCD or OLED display, right? An external device, but out of the box it's quite limited. Edge and the fog class devices, mostly fog. So they are comparable with powerful PCs. CPUs 2 to 8 cores, usually with floating processing unit, FPU. Wireless communication either by the external module or built-in, and usually wired interface that makes them natural for routing and gatewaying. User interface, well, again, usually not very rich, but because of the existence of the GPU and powerful CPU, there is usually a monitor connector that you can connect external display, either through CSI or DSI or through HDMI or any other, right? They do have an operating system running on that, which is mostly Linux. Android is a Linux as well. It is able to make a remote management through web, through SSH, or even make a remote desktop to it, right? Depends, either you install it with the graphical user interface or just the textable one. Large battery, but usually as a backup because it drains up to 50 watt of power, so it's not suitable for the battery very much, right? Constant power delivery is needed. And obviously, the last part is cloud devices. It's a network area storage, PC mainframe, high power, high performance devices with large storage. Obviously, they are instantly powered with a really huge resources, like taking kilowatts or even megawatts of power. They are having fully operational systems, like a desktop server extended, which in other terms means that it's quite frequent to have an abstraction layer on that, so you have a virtualization. So on the very low level, that can be like a command line devices, but on the top of that, you have this virtualization layer with shared resources. So this is where this service-oriented architecture and software as a service appears. Storage, it's terabyte, petabyte. RAM of a single machine is gigabyte to terabyte. GPU is present for machine learning. Software components. IoT ecosystem can be a closed, open, or semi-open. If the IoT ecosystem is closed, like here, there's a solution where third-party extension is impossible or it's very problematic to be integrated into this ecosystem because there is a lack of knowledge of the system construction, communication, provisioning, right? It is common that the manufacturers create their own ecosystem, right? And they close it. They do not provide any documentation other than configuration. Pro, easy to introduce and use because they are close, pre-configured, so you bring it to the installation, you install it and it should be working. Eventually, small configuration, like connected to the Wi-Fi. It is considered to be quite reliable and solid in terms of the feel, look, interfacing, right? Common interface is common look, like, for example, all is in the black plastic or white plastic or has the same LCD or even the same user interface. It used to have a good support during maintenance period, and they are usually certified, whatever this certification means. Cons, you cannot extend it with the new features unless you pay for it. It's quite expensive, usually. There is no support, or the support is expensive after the maintenance period, right? It's quite common that the update will come for 2 years, but then forget it. No one takes care, right? Even if there's serious bugs, no one will take care about you. Security considerations, right? For example, this use of the global cloud, and you cannot regret it. Like, for example, those vacuum cleaners that they connect somewhere, or Tuya bulbs, right? You connect Tuya through Wi-Fi to some cloud in China and or somewhere else, and you also connect your mobile phone to this cloud and you control it over someone, so the someone knows everything about your house. Open IoT ecosystems. It is a solution where the software and the hardware is available and open for everyone, usually through some of the public resources like GitHub, GitLab. Some of those firmwares or solutions, like for example Tasmota, they provide the support for closed devices and they show you how to crack them, hack them, and replace the firmware to make them open source. So not all of them are doable this way, but at least some of them are possible. And sometimes it is the only interface API that is published to the community, and code is proprietary still. You know how to interact with the system for free, right? So, for example, you don't have a source code for some component, but you know how to use it externally, how to use its features, right? So they don't share the know-how, but they share an open interfacing. Pros. It requires some skills to set up and use. I would say it's pros and cons. Updates may break configuration. Okay, as it is developed mostly by hobbyists, someday someone may come and tell, okay, next version is making this totally different. And then you have to either give up updating or reconfigure everything. There is a community support instead of professional support, which is sometimes better, sometimes not. Usually it's okay. Definitely long time availability for this project is a good pro, because the projects, they may evolve over time, but in case of the public repositories, you can always revert to some version that was in the very beginning. Cons, unpredictable development, right? It may be abandoned, so one day you come and you see there are no updates and no problems are solved. If you are not a developer, you are not able to solve it yourself, then sorry, but you need to live with it or quit. Lack of on-demand support, right? So you write for the community and you look for the problem. If you have another problem, then you drop a message and you wait. You cannot install and solve it instantly, right? Unless you do it on your own. Rare errors may have no solution or solution can be delayed. Complex setup and lack of instruction is quite common because you come to the repository and the owner of the repository assumes that everyone is a developer, so they don't provide a manual how to install it, or eventually it's so complex that you cannot understand it. And there is usually no certification because no one is going to pay for it. Okay, now the programming models. Quickly. Low-level programming. This is what we do with these end-node devices, right? Sometimes this edge class. Sensors, actuators, sensor networks. It applies to the specific components, mostly open hardware and open source ones. It requires the development of the specific scenario to use. Usually limited. Because if you write the software, it's quite difficult to write an omnifunctional software. You just focus on implementation of only those functions that are the most required ones. So you write it on your own, and you don't want to spend a lot of time on development, naturally. Programming for this class of the devices, it's usually C++, and you have the development skills. Not only because there is a MicroPython for that, there are some micro Java, like the tiny Java, but the most popular is C++ still, right? Because C++ is gives you a very compact code in terms of the memory and the code efficiency, and this naturally fits this constrained devices. Developer manually prepares codes from scratch. Obviously, yeah, there are libraries that will handle, for example, components like a display, actuator, servo, sensor, right? So they will help you to do that, but you have to craft intelligence of the device your own, right? So being smart. And most of all, it requires compilation toolchain installed on the development machine, right? Because you need to write the software and compile it, and also upload it to the device. What is great is you have an absolute control over the device. I consider it to be secure, because if you are crafting it from scratch, there is very rare that someone will step in. Obviously, it may be hidden somewhere in the libraries, right? So because if you include a library, perhaps you don't read all the contents of the library, you just include it and use it. So that may be dangerous, but less dangerous than if you use an operating system and you never know what's under the hood, right? So in terms of the security, it's no bottlenecks related to non-used code. Its code is optimized. It's like a feature of the programming on the low level. And it's fast. There is no overhead of the middleware like an operating system under it, right? So you directly call the hardware, not some abstraction layer. Unless you are programming in MicroPython, then there's a virtual machine to do that, but that's another story. Cons. You're on your own. You need to implement everything from scratch. You need to understand both hardware and the software, right? Ecosystem changes usually means you need to recompile your code because something has changed. For example, API you interface with has changed. You need to recompile your code. First, introduce changes, recompile, reflash devices. And you can even break the device sometimes, so you need to be careful about it. Okay, so the process is as follows. You author the code, for example, C++, you compile it, you link it, and you have a binary pack. And then you upload it to the chip in the correct location, to the flash. There's always something like a memory map that tells you where to flash it in. So that's hardware specific and microcontroller specific. Hybrid. It's middleware plus programming. You can consider it like, for example, this MicroPython on Node.js. You have some interpreter that is in between your hardware and you as a developer, and it gives you hardware abstraction layer. That you use common libraries, common syntax from Python, from scripting language. You don't compile it. You just upload it, and it's executed line by line. So it's interpreted language, not compiled language. Sometimes it's faster, but obviously it has some pros. It's much easier than low-level programming. It's good for beginners. Still, you it requires understanding of the hardware, right? It's flexible enough to handle many tasks, but not all. In particular, tasks that are real-time would be problematic here, right? Because there's a middleware and you don't know how it works, how it interacts. Cons. Not all scenarios are possible. As I said, for example, real-time can be hard. It is slower due to the interpreted languages and requires more resources on the device. Many involve complex or no debugging support at all, so it's mostly like tracing. While for C++ programming, it is common that you can have a dedicated hardware debugging interface. It's not the case for Python, because you will actually debug not the Python, but you will debug the interpreter of the Python, right? That is under it. Doesn't tell you any. Middleware updates can cause script incompatibility, and you will need to rewrite it. So if you reflash with a new Python version, perhaps something may be different on the libraries, underlying libraries, so you have to reflash it as well. Okay, so this is like you have a script, Python, Node.js, Java, and you upload it to the device. It is quite common that the device, for example, exposes a file system that you upload it instead of flashing, right? So you just upload it through like a copy-paste in the file explorer. And then but it's doing the same way, I think. Just like a copy. It's like a file copy, in other words. Yeah. Okay. Middleware configurable. It's when you have a system that you do not program, but you can only choose configuration options. The number of those options depends on how is it built, right? So for example, it can be as simple as configuring only the Wi-Fi interface to connect to or any other network interface, or as complex as, for example, executing your own scripts on some particular events. So maybe it's quite configured. It really depends on the manufacturer. Those are closed systems, not open, right? This model is quite similar to the presented one hybrid, but you usually expose, they usually expose a sort of the API that you connect to using some external configuration application. You just configure the devices and so on. You click it, save configuration, reboot, and that's supposed to work, right? Eventually, scripting is possible, but it's not very rare. It's much easier than programming because you don't need the programming skills here, right? You have a user interface and you choose. Eventually, this programming is very limited. Still, you need to have an algorithmic understanding. It's closed configuration environment, which means, as we were discussing, it can be like a pro, but it can be like a cons. It usually uses regular apps like a mobile browser to configure, so you don't need to have a development toolchain. But the limited number of user scenarios is supported. There's almost no extension over these scenarios that are planned in advance. So we can just choose from the list of the scenarios or configuration, but we cannot extend it usually. Eventually with plugins, but it's quite rare. So you have a configuration settings, you upload it, the device reloads the config, usually by rebooting, and changes its behavior, right? Okay. And finally, fixed firmware. Okay, to be short, there's nothing you can do here. Manufacturer has predefined everything. Or eventually, it's very limited for one-time configuration like connectivity, and that's it. Cons. Solid solution, yeah. Common approach to the ecosystem. All components should have similar look, feel, view. It's considered to be reliable because you cannot break it, but on the other hand, not always. So it depends on your approach and luck. What do you choose? Vendor updates and takes care about the ecosystem compatibility, obviously during maintenance time. Right after they finish, eventually you need to pay quite a lot just to continue updating. This is very important because whatever you think about the IoT, it is like the generation in the IoT is something like 10 years, which is far beyond regular updates, right? Imagine new protocols comes, other protocols are banned, for example, like a TLS1, right? And you no longer can connect to it because it's forbidden. No one is using this old security protocol right now. It's considered to be insecure, but your devices cannot be updated. So it's all then gone to trash, and you need to rebuild everything. There are predefined scenarios. It's pricey and one vendor dependent, so you usually cannot integrate it with other solutions. Turns outdated once support is over. Yeah. Low configuration capability is usually limited to the connectivity config. Okay, so you just configure it, send the config, and that's all you can do. Okay. We still have some time, so I will go with a couple of the scenarios. Okay, something that I still do not understand why it's not working in the mass scale. Let me ask you, how many times did you experience a situation when you're at the university, you're working, and the delivery guy is calling you, how dare you not to be at home when I bring a pack for you? So, you have a road, you have a mobile navigation, it could integrate with the cloud services, it's a courier path. And the customer could have a tracing application that sends where the person is already. And that could be an easy information, either you are home or not. Right? Could be like an InPost, for example, right? Sending information periodically, or actually on demand, because the courier knows that, for example, it needs to know either you are home or not. So it sends a request to your application, and that application responds, I'm home. Or eventually even interact with the customer saying the courier is approaching, so please wait, if possible. Or send regret, just let it come in the afternoon. Easy, easy. No one is doing that. I don't know why. Could be all automated. Elderly patient monitoring service. So you could detect anomalies, right? And alert medical services, like I told you, the dementia or fault detection or problems with, for example, oxygen level, right? So low, just not to suffocate, and so on. Intelligent home or the smart home, for example. A system that traces activity at home and monitors environment, right? It can check safety conditions, like the smart lock, right? Or just make a monitoring system of the cameras and, for example, easily detect, using, for example, the RPI and the motion server, detect some movement in your garden, right? Either it's an animal or a person. And close the window when it's too cold or it's raining. Switch off the kettle if you forgot it. Or even lock the door automatically if you forgot to lock it. The internet fridge, right? So this is something I told you didn't trigger, but imagine it monitors food consumption somehow. So it automatically makes an order of the food and takes care about your balanced diet, suggesting you what to do. For those who struggle with their weight, it could be like a locket overnight, closing at, for example, 8 p.m. and opening at 6 a.m. or 5 a.m. in the morning. Yeah. Okay. Energy harvesting. So this is optimization of the energy use. Like, for example, running your vacuum cleaner scheduled depending on the availability of the local energy to consume it locally, because it's better to consume it locally than send it to the grid, because you never had a 100% back, right? So. You can even plan it in advance with the weather forecast. Okay. Fitness, right? Monitor activity and performance. Adapt workout plans. It happens now, right? So you have these applications that guide you how to go, or even the smartwatch can help you. It can monitor your health, consult food, and support sports specialists, right? Depending on what's going on with your performance. And can be integrated with the smart home, with the internet fridge, just to order some different food. Smart city, intelligent transportation. I saw it first time in Singapore. They didn't have timetables on the bus stops. Instead, there was an application, and the time schedule was flexible, depending on the amount of persons waiting, right? So you could see the bus coming in the live, real time. Obviously, there wasn't information when the next bus comes, because you were just choosing where you want to go and where are you. And yeah. So imagine, for example, that there are commuters. You trace them with a mobile. Then there's a bus traffic, amount, direction. You put it to the cloud. You learn cloud behavior, who is going where and how many persons are, how are the crowd streams. And then you can adapt the schedule based on that one, right? I believe it happens already. I mean, I hope so. Okay. Traffic jam. Time, direction, and amount of cars. Actually, we have it in Gliwice here. I wonder if you know it, but it is optimized like during the morning hours, it let more cars come into the city, and the afternoon hours is optimized the way that it let more comes out from the city center. Traffic management, parking places, traffic light control, right? And also investment control, where to invest, where to put shops, where people are looking. So, yeah, Industry 4.0, we discussed it already. Yes. Okay, let's go for some creative thinking right now. There are some scenarios you could consider. Maybe some of them are funny. Maybe some of them are unreal, but let's think about this. It's from the European IIII.org IoT scenarios book. So imagine there is a city, and there's a bus driver, and this guy is like going to the bus stop. So your smart cars, which are more and more popular, may have a connectivity between the bus just to make a line empty. You know, even slow down, not necessarily stop, but slow down when the driver wants to join the traffic, right? So for example, he is using the left direction indicator, then the system may initiate this procedure of emptying the lane to let it join. Yeah, that's quite an idea. Sorry, not this one. Here. Fresh air, actually we do it, right? Because we have this problem with pollution, and we have pollution maps. So on the smartphone, you have a map that shows polluted zones. So if you want to go with your child in the winter for a walk, then you need to check in advance either there is a pollution or not. Yeah. We already do it, to some extent, of course. Intelligent shopping application. Right, this is something that drives me crazy, because when you come to the big market, like a supermarket, you spend a lot of time just to find the product, isn't it? Assuming you have a shopping list in advance, you could have an already guide where to go. Obviously, that requires an indoor navigation system. It could be based on the ultra-wideband or wideband or some other system, but there do exist this sort of solutions, right? For example, in Galeria Katowicka, you have a system that is able to guide you through the stuff. So, yeah. Yeah. You mean like a price tax? Yeah, it's an e-paper. It's an e-paper. Yeah, no. Huh? Yeah, you can have a different price when you come to the cash desk because they changed it in meanwhile. Okay. Save energy with friends, like a game, or sort of energy saver social media. Could be good for the European project, I believe. So in general, like, you can tell how much energy did you save. Okay, sounds to be dummy, but to some extent, maybe it's sort of the future, right? Just to socialize this way. Indoor sensor network. What I mean here is, for example, to build a rich user experience based on your smart home and other home appliances. Like, for example, adaptive audio that will go and play in the different rooms when you go through your apartment, right? It will follow you. Or maybe based on the mood that, for example, this watch can detect if you are stressed or not, will adapt the music in your car or when you come at home. And obviously the personalized content, right? So when you switch on the TV, it should know that this is you switching on the TV, so perhaps your favorite is Disney Channel instead of Netflix, right? And you don't need to start it all every time you launch. Yeah. Efficiency in delivering pasta and milk, okay. It is like ordering an amount of the food for children. So when the children come to school or to kindergarten, just to check how many of them are here, right? For example, right now, many children are having colds, so they stay at home, so they don't come, and there's no need to order lunch for them, right? So that could be quite easy, because you could have like an access card that the parent or a child, if only you can do that, could like a drop to open the door when coming in, so then you know it's inside, like this one. They know I'm here. They don't know you're here, but I know you're here, so that's enough. So that could be also aggregated with the quantity of like a water, electricity, gas used, and follow predictions, right? In short. Okay, Smart metering data for planning and optimizing the low voltage grid. Yes. So it happens, right? A smart grid, in short, it's monitoring of the energy grids, electrical, but not only electrical. It can be like water, natural gas, also wastes. And then if you have emitters and you're able to reach them over this grid, then you can, for example, quite easily find out where is the broken connection or where is the problem and identify it. I think that the companies like this energy delivery, like Tauron or PGE, are using this sort of solution. For sure, for a large scale, for this high power voltage lines, but also for the low power voltage lines. So it easily lets you enable to find the breakdowns and replace, for example, network controller, right? I mean, the grid controller, just to make it working seamlessly. And also, it can be used to detect an early symptoms of the deviation. Like, for example, voltage drop, that would suggest there's something wrong with this resistance, right? And it can break next period, so it's time for the maintenance or replacement. Yeah, could help you to identify. Smart parking. We are working with my student on that, actually, twice already. Where parking in the city drives crazy every driver to find the parking place. So what is the problem is actually maybe not to find a parking place, if there are any, of course, left, but just to count how many wallet parking places are left. It's not so easy. I mean, on one hand, if you consider like markets, they usually have these hanging systems that they check every single presence of the car, right? Like ultrasounds or any other laser-based presence of the proximity sensor, in short. On the other, it's very expensive because you need to equip every single parking place with this set. Either it's underground or overhead, and you need to make this connectivity in between them. So maybe the easier solution would be a camera. The camera could count a number of cars it can see in the range. As we know the number of the places, then we can subtract it and calculate the number of empty places and present it to the user, right? And let the user even be automatically guided. And moreover, if the user books a place, then maybe the other user won't be guided to the same location meanwhile, right? Because when he comes or she comes, then you may easily find out that it's already taken by another person, right? So maybe that could be the solution if you decide. And then you need to go, right? Again and again and again and use the fuel and use the energy, which doesn't make any sense. So maybe like such a booking like, okay, I want this place and I'm going there, right? Drive me there. So it would be a nice solution in the city, just to have an application on your navigation system of this kind, right? Tell you, okay, there's a wallet place there, go there. Interestingly, one of the most interesting solutions I have seen in this context, it is in Dubai Mall. Wonder if any one of you have been there by car. But we just came for this fountain show, there's a couple of times, by the Burj Khalifa. And then I realized that we came by one door, but there were so many people that they make their one-directional movement of the crowd. So we couldn't return with this door. We have to enter the mall with the other door, which was located some 200 or 300 meters away, and I lost where I am at the moment, and where's my car? Not so easy. But then I approached this like an info panel, and it came, please put in registration number. So I had it on my key, luckily. And then it showed, is this your car? Because there was another car with similar number, so it showed me two options, which one to choose. I said, this one is mine. And I instantly had on the road how to get to this parking place. Nice. They know all the number plates, right, located. So they have cameras everywhere. They scan number plates, and they know there are cars, and they can find your car. Scary on one side, but quite very handy on the other, right? How to use it. Okay. Using electric cars as an energy source, right? So this is what targets this energy storage, what I said. Look, we have quite a nice weather today, and everyone is making energy from the solar panels. And there's an energy overhead at this moment. So you could store it in your car. Your car battery, if you commute daily, is perhaps much bigger than you need for your daily road times. You can charge it over, let's say, 1 or 2 hours. But why don't we use a car like a backup battery for our home appliances? When we come home, you can drain it, just keep enough to get to the charging station next day. Assuming it's a sunny day, then you can recharge it again, right, with a low price. And then come back home, connect it to your grid, and reuse this energy for your home appliances. Yeah, it's like, you know, mobile cistern, but with energy. Well, you travel anyway, right? So it's just a matter of perhaps shortening the lifetime of the battery, but yeah, still. Okay, so I would say that's it. Let me make a quick summary for today. So we started from that one, right? And we still keep it. We start with the sensors, embedded systems. So here is embedded protocols that we will also talk about. Chris will tell you this next weeks, perhaps. Local storage, local data processing, if needed. It also includes routing, gatewaying, aggregation of the data. Then you go to the local network or the internet, depends on what's your direction, what's your solution. Finally, you get it like a cloud or personal cloud. You do data mining there, and then it goes back to the actuator, opposite way. Again, what is IoT then? As I said, it's quite hard to tell. But there are some features that are obligatory for the IoT, which are identity and identification, communication in the form of machine-to-machine model, right? So this is essential. Unique ID, data processing, and communication. Paradigms are mobility, new protocols, wireless networks, and actually its omnipresence, and the data science. So the conclusion is as follows. If I would define an IoT on the hardware level, I would say it's an embedded system network enabled. And it constitutes a core of the IoT end node hardware infrastructure, but it's just a part of it. This is the most left part, right, of this schema. Then there is a capability of efficient local computing devices with low power, still low power. They act mostly as fog, sometimes as edge devices in the IoT ecosystem, but they are capable enough to do even simple AI. Modern network infrastructure along with new protocol plays crucial role in the IoT. Here we have new protocols on both new network structures like this mesh, new protocols optimized towards low-powered devices that can, for example, be offline for a time, like go to sleep. And finally, cloud solutions delivering storage and computation services for the IoT data in this large scale when you need to do a serious data use. And finally, data and this knowledge is crucial just for all these operations, right? It's all about processing and sending the data forward and back. And it's done machine-to-machine way. So we distinguish 3 major layers of the ecosystem. A perception layer, we call it end node class. So they're small, constrained, sensing, actuating. Computation layer, which is fog class, sorry, aggregation layer, which is the fog class here, which does elementary, not so advanced data processing, routing, data aggregation, networking services. For example, it can do a data depersonalization in the context of the security of the data. And finally, you have the cloud services, which are always on, high capacity, high data storage for small and big data, high performance computation, with an ability to do the data mining, deep learning, AI, all this class of the systems. A matter of scale is around 42 billion of the IoT class devices interconnected 2025, generating close to 80 zettabytes of data. In 2021, there were already 35 billion. So we assume that it is linear growth at the moment, as I was observing on the, so this exponential growth was replaced by the linear growth. Still, market is hot. Countries that play important role, there are countries that are mostly on the hardware manufacturing, which are naturally most of the Asiatic countries. Even if there are European manufacturers, they mostly order hardware in Asia, mostly in China, but not limited to. It's also South Korea, Philippines, Indonesia, right? Okay.